back to Crunch Labs. I'm Mark Rober, and today we're going to be talking about the drawing machine and all the juicy engineering nuggets that come along with it. And this drawing machine is cool because it's the first build that covers the A in STEAM. As you probably know, STEAM stands for science, technology, engineering, art, and math. A lot of times when people think of engineers, they just think of the science, technology, engineering, and math part. They skip that art, but art matters. A lot of what I do is a form of art, right? Because I need to tell a story. I can just film some squirrels in my backyard, but if I create a story around it, then I can really draw you in, and then once you're there, then I teach you the science and the engineering. But without that storytelling, it just doesn't happen. Even when I was at NASA and at Apple, if you could tell a good story and explain to people and make them feel something as to why we should take a certain direction, that makes you a better leader, and you can lead a team of engineers to accomplish cool stuff. If you don't have that element, you can't sell people on an idea, then you really miss out on the positive impact you could have. Now, for me personally, I love art. Now, what's the definition of art? I think a great definition is if you look at it and it makes you feel something, then it's art. So here's an example of a piece of artwork hanging in my house, and I don't know, this was made by a buddy of mine, and I see this and it just makes me feel something. Like, is this Earth at a future time? Or maybe this is another planet and they're aliens, and maybe they're looking at the sky and seeing us as a little star? That raises all sorts of questions. Or maybe they're future Earthlings that have gone and colonized another planet. Either way, I see that, and it gets my mind going, and it makes me feel something, so that's art. So this build is just a great example of good machine design that creates this really cool art that you can look at, and it can make you feel something. So let's get started. And as usual, we're gonna start with our question of the day. And of course, as you know by now, this is a question that's really difficult to answer, but we use all the junk we have lying on the table in front of us, and then in a few minutes, we'll be able to revisit that question, and you'll be like, I know it now. All right, so without further ado, let's get to our question. And it is, how do you make a perfectly smooth curved line just from straight lines? Getting worse with my throws. What do I mean by that? Well, I mean, here's a drawing with really cool curved lines made from curves. But how do you combine a bunch of straight lines to make a really cool, beautiful curved line? And I'm gonna show you. We're gonna figure that out. We've talked before about how we use the energy from the sun and we harness it and transfer it in different ways so that we can make these machines that use that energy that make our lives better. And as engineers, one of the greatest tools you have to get a machine to do exactly what you want it to do is the linkage. And spoiler alert, that's the gear badge for today. So let's get started on what I even mean when I say linkage. Well, I've got some paper examples here, and we'll start with this one. So here's a little construction paper thing we've made, just a little brad here. And as I turn this, the hand waves. Now try and guess what the back of the paper looks like here. Well, that's probably pretty dang obvious. This is all we do. We spin on this brad, and it's a little waving hand, right? Well, now let me ask you another question. We'll bring another one in here. Now when I go left and right, what the heck? The hand goes the opposite way. So what do you think is happening? Try and imagine what's on the other side of this paper. Okay, think you might have it? Let me reveal the answer. Boom. So again, you've got these two linkage arms rotating about these pins, and then a brad here that slides in this slit, and then it gives you that cool opposite motion, right? This is an example of what we call a linkage. It's basically a system where as we change an input, as I physically move this arm, some portion of the rest of the machine moves with it in a constrained fashion. Those are fancy big words. Don't worry about it. Let me give you some more examples. How about this beautiful little turtle here, okay? I move this tail up and down. That's not really a linkage. His head just goes up and down. And you're like, big whoop, Mark. I bet you know what's on the other side. Yep, sure enough, it's just a single piece of paper. And you can see the way we've made it to kind of slide in that slot is we've sort of bent the paper like this. So it just kind of slides nicely up and down like that. All right, if you think you're so smart, how do you think this one works? Once again, it's a turtle, but now when I pull the tail, the head and the arms all come in and out. This is a great example of a linkage in action. How do you think this might be working? Well, let me flip it over and give you the answer. So once again, it's the same thing. We've got this main head and tail bit, but now you can see we've pinned these legs. So each of these legs sort of rotates about how it's pinned to the paper. And now we have these linkage arms in here, so now it constrains it fully and makes those arms and legs come in, and then the arms and legs come out. And again, from the top side, it just looks really cool. Okay, here's another example I really like. When I pull the tail, the worm head comes out. If this were a simple linkage, when I pulled the tail this way, the worm would come this way. But instead, when I pull the tail here, the worm sticks his head out the apple. How do you think this is working? Well, let's check out the linkage. When I flip it over, here you can see, aha, it's like an S shape. It's pinned in the middle, so that's gonna rotate. And when that rotates, these ends come out like this. Another great example of a linkage in action. I got a couple more, because these are really fun. It's kind of like brain teasers, right? So we've got an arrow in here with this big hole in the middle, right? I can literally put my hand underneath this. And now when I wiggle this arrow back and forth, it moves, and yet there's no arrow going through the middle. That looks kind of wild. You'd expect it to just be a single piece of paper that goes all the way across the opening, and yet it's not. You got any ideas in your head how this works? Here's a clue. There's two brads here. We'll turn it over. Aha. So we've got a little linkage here that as this goes in, it pivots about here, pulls this back, pivots here, and pushes that arrow forward. Okay? Here's a really fun one. This is the sunset. So you see as I barely pull here, you see the sunrise and the sunset. And as I do that, sort of the sun's rays move relative to each other. How the heck are we doing this? Any ideas? Let's flip it over and get the answer. Aha! So as I push in here, oh, there we go, right? You can kind of see how it's working. So none of this is attached. It's just pinned right down here. And then we've got a slider arm that slides in this slot. And when you do that, you can see how it works from this side. A lot of children's books and pop-up books use linkages like this. And finally, this is maybe my favorite. Ready for this? So this is kind of ridiculous, but as I move this, the mustache moves, the eyes move, the eyebrows move. We made these in an afternoon, just having fun, getting together with the team. So you can do the same. When we flip this over, you can see this is the way we're getting all of that movement, right? Just by moving that up and down. So that's a bunch of examples on paper, and this video isn't a typical science or engineering lesson. It's more about opening your mind to how useful linkages are in our everyday lives. And also, let me key you into another little secret. 5 years from now, you're not going to remember anything specific I say, but you will remember how you felt. And what I want to do in today's lesson, and really all of them, is just to get you understanding the world around you a little bit better, to have that aha moment. And if I can get you addicted to that feeling of having your mind blown because it's expanding, you're just like, oh, I get it now. That's why this happens. That's why this looks like this or works like this. Then my job here is a success. I want you to feel and experience the joy of just learning new things. Okay, so we've covered paper linkages. Let's talk about how linkages are used in toys. Here's a really cool toy that expands and contracts. You can just see this uses a bunch of linkage arms to kind of contract and then expand. Well, that's pretty cool, but what if we made that 3D? Well, that's what this is. It actually has a name. It's called a Hoberman sphere. But basically, it's just a bunch of linkage arms that work together in concert to create a smooth, fluid motion. Here's another toy I've got here. It's a little RC car, right? And a very common place you see linkages is in steering wheels. So you can see it's pinned right here, and in order to turn left and right, there's just a little motor right here that's either shifting this linkage arm left, which turns the car that way, or right, and that turns the car this way. It's the same concept of an actual car, but this is just in a toy form. Here's a useful clamp from my tool chest, and just like the paper ones, you can see it's pinned right here. So this moves in this motion, and then because of these linkages here, you can get some really good mechanical advantage and really clamp down hard on things with a little over-center mechanism. In my own builds, I use linkages all the time. You might recognize this from the automatic strike bowling ball. The way we got the ball to either steer left or right is through this linkage arm right here. This piano bench, this is from Chopsticks. This is Chopsticks piano bench. When we look underneath, it would be useful if you could lower and raise the seat, but in a manner that sort of supported any weight. Well, when you turn these knobs, you got this little ball screw here, and sure enough, there's a linkage that allows it to slide up and down. This ladder right here, is a linkage. It's different than just a hinge. A hinge would be if this ladder just rotated about this point, but there's more because these other links all work in concert so that these steps go from perfectly up and down so they store flat to being perfectly parallel to the ground so you can actually step up there and it's really secure. Linkages are literally everywhere, and once you see it, you cannot unsee it. So let's take a little field trip out into the wild and I'll point out a few of them. In fact, we could start right here in the arena at Crunch Labs. Those linkages allow me to come up this high into the room, allowing me to do some work on the ceiling. A canopy like this uses linkages to expand from something really small and compact into something really large once you fold it out, and now it provides a ton of shade. A folding chair is another great example of a linkage in action. If you remember the home wrecker from Squirrel Obstacle Course 1.0, this is an example of a linkage with a pneumatic piston as part of it. And for Obstacle Course 2.0, the laser maze door was also triggered using a pneumatic linkage. This tripod has 3 legs, but there's no linkages, it's just a hinge. Each leg moves completely independently from the other one. However, for this tripod, as soon as you add a linkage in, you notice the difference? In this case, all 3 legs move in and out in unison. That's the benefit of throwing a linkage on there. And finally, our really cool go-karts here use a linkage here to put the wheels up on the casters, which allows you to spin all super crazy. All right, so that's just a small sampling, but hopefully that gives you a sense that as engineers, linkages are one of our greatest tools to get machines to do exactly what it is we want them to do. In this case, it's to draw really cool art, but as we just pointed out, there's an infinite number of use cases for this same principle. Now, I took a whole course in college called kinematics, where we use fancy computers to get like the right path and output and what the linkage arms need to look like. In your case, when you try this out yourself, it'll just be a bunch of trial and error. Again, don't expect to get it right on the first try because you won't have a computer, but start with what parts you want to rotate, pin those down, and then see, all right, how do I need to connect to those rotating parts to make them do a specific thing? But if you weren't doing this with paper, with kind of like trial and error, using the computers, you could get really cool machines like this one. Now, this is a really challenging problem, but it basically takes a rotating motor and rotating linkages to make a perfectly straight line. And this would be really hard to do if you didn't have computer software to kind of reverse engineer and to solve this system. And when I saw this video, it reminded me of one of my favorite things to do as a kid because I was more engineering minded, but I liked art, and this is a cool way to combine the two. And it's also the answer to our question, how do you make a perfectly smooth curved line just from straight lines? So let me show you guys something really cool. So what you want to do is just make 2 straight lines. It really helps if you have graph paper. 8 boxes over this way. And then all you're going to do is you're going to connect this dot to this one, and this intersection point to this one, and this intersection point to this one with straight lines, and watch what happens. You get this really cool pattern. And that is how you get a perfectly smooth curved line just by drawing straight lines. Isn't that really interesting looking? But what's really cool here is you could scale it up and really take it to the next level. So basically you want to make a plus sign that is the exact same length on each leg. So in this case, all of them are 13 boxes down. And now we just do the same thing where we connect this to this, and this dot to this dot, but we do it in all 4 quadrants. And now check out what you get. Now you can see I've only got 1 quadrant left, but it's looking pretty rad. So you can see how cool that looks with just a few minutes of using just straight lines. I have seen people, you could also put like nails in a board equally spaced and then do strings, and you can kind of do a similar effect. But I wasted a lot of hours from my youth making shapes like this. Because what's also cool is you can come out and extend it this way and even add little spikes on top like this. And then you could just keep adding more and more spikes and doing cool shapes. So that's the answer to our question of the day. How do you make a perfectly smooth curved line just from using straight lines? So you're welcome, because the next time you're bored, you can waste a lot of time making some really cool art. All right, well, it's time to put it together. As usual, you could totally just go through the instruction booklet. It's got great instructions there. You don't need this video, but I'm gonna go through the example right now so you can see it. You can pause along the way because we'll show all the step numbers that correspond in the book. And I'm gonna power through this in about 4 minutes. It'll just take you anywhere from 20 minutes to an hour to do it yourself at home. So here we go. Place both your DC motors on your work surface with the motor shafts facing up. Then peel and stick the blue foam to each of the motor bodies. Next, locate the yellow adhesive backed wood piece, then peel the paper backing off the corresponding blue foam. Then stick the wood piece to the foam yellow side down. Grab the battery pack and pull out the clear plastic safety tab. Then peel and stick the blue foam onto the side of the battery pack that has the on-off switch. Next, peel the paper backing off both motors and the battery pack. Then stick each of the 3 components to their corresponding holes in the wood frame. Pay attention to the shapes of the holes in the motor foam. One is a square and the other is a circle. Next, secure both DC motors to the wood frame by threading the black elastic cords through each of the mounting holes. Pull on the cord while using your thumb to apply some tension to it. This should make it a lot easier to thread the cord through the second hole. Next, flip the wood frame upside down to expose the wiring, and then grab the red Y splitter cable and connect it to the 3 visible red wires. You'll find one on each motor and then one on the battery pack. And then you want to find the black Y splitter cable and connect it to the 3 visible black wires. Again, one's on the motor and the other 2 are on the battery packs. Then peel and stick both of the circular yellow foam pieces onto the blue plastic wheels. Then press fit both of the wheels onto the DC motor shafts. The wheels will stick out a bit, and as you can see here, one wheel should be slightly higher than the other. Now it's time for a test. Flip your switch to the on position and see what happens. Your motors should begin to spin. If they're not spinning, go back and just double check you got your wiring right. Next, peel and stick the 4 red foam feet to the back corners of the wood frame. You'll find the lower left one also kind of helps tuck the wires out of the way. Now with your project flipped back over, use the remaining black elastic cord to attach the large yellow wood clip to the top of the frame. Then find the dark blue sphere and place it in between the yellow wood clip and the frame. And now you just made a cool little clipboard. This is actually called a ball joint, and you actually have a ball joint in both your shoulder and hip bones. A ball joint basically uses a ball or a sphere to really help things rotate smoothly in all directions. Next, find the white Velcro sticker, then peel and slide it over the plastic blue top hat piece. Push it down until it sticks. Then peel and stick the black Velcro sticker to the short blue linkage. Then use the Velcro to attach the short blue linkage to the blue top hat. Place the long blue linkage over the end of the short blue linkage and attach them together with a light blue rivet. Notice that the hole sizes on this piece are different at each end. Make sure you use this end that doesn't have these smaller markings. Then slide the short red linkage down over the top hat. Next, place the long red linkage over the end of the short red linkage and attach them together with a light blue rivet. And again, remember, the hole sizes for this piece are different for each end as well. Now rotate the long red and blue linkages together until they overlap and make an X. The red arm should be on top. Then use a light blue rivet to attach them together right in the middle. And now you've made yourself a scissor linkage. Now use the white bolts to attach the scissor linkage to the blue plastic wheels. Screw them both into the threaded holes in the blue wheels until they're tight. Next, slide a white piece of paper under the yellow clip and then use a white bolt to tighten the pen into the pen holder. Make sure that the linkage is parallel to the paper, not too far up or not too far down. Alright, well now it's time for a test. So choose one of the 4 colors from the super cool retro pin, click it into the on position, and then sit back and watch what happens. So your drawing machine will continue to repeat a set pattern until you turn it off. And so the longer you let your machine run, the more detailed your drawing will turn out. Here are 2 drawings I made with the same linkage. The only difference is I let this one run for 60 seconds and I let this one run for 5 minutes. Okay, and now it's time for maybe a little bit of a game, kind of a scavenger hunt. Here are 4 examples of drawings that you can create with your drawing machine. Now in order to do this, you might have to adjust the position of the linkages in relation to where they attach to the wheels. To do this, you just unscrew one of the white bolts and then shift the base of the linkage to the other threaded hole. But you also might find in order to get all of these, you might need to use the second linkage that's included in the box. And here's how you set that up. First, find the 2 remaining linkage arms in the box. Then peel and stick the black Velcro to the largest hole in the blue linkage arm. Then remove the white bolts from the pen holder as well as the blue wheels. Then pull the blue top hat off the scissor linkage. Then use the Velcro to attach the long blue linkage arm to the top hat, and then place the red linkage arm on top of that. Then use the white bolts to screw the new linkage into the blue wheels. Make sure the blue linkage ends up on the right and the red linkage ends up on the left. Then screw the pen back into the holder and you're ready to go. Okay, well now that you got it put together, it's time for what we like to call around here the engineering hustle. This is your chance to earn a little extra dessert by challenging your parents to a little friendly competition. You can also challenge your siblings or friends or teachers, really whoever you want, but ultimately this is your opportunity to be like me as the uncle when I challenge my niece and nephews to bowling, and they do okay, but then when I step up, since I'm not that great of a bowler, but I am a good engineer, all I have to do is lean left and right, and the ball obeys me, and I get a strike every time. So maybe in this case, you take one of your shapes and you challenge them to a draw-off. So whoever can draw something as cool as this is the winner. So if they give it a try and of course fail miserably, well then you pull out this machine you built and draw it right in front of their eyes and dominate your competition, and now you've earned that bonus scoop of ice cream right before bed. Another fun thing you can do along the lines of art, which is the theme for this box, is make more of those curved lined from straight line drawing, like our question of the day. I loved making those as kids, and you can kind of go nuts with them and add extra lines and spikes that come out and just make these really cool shapes. Either way, no matter what you do, be sure to work with your parents to post it online. Just make sure to use our social handle at CrunchLabs, because it's just so delightful to see the amazing things that you guys come up with. So that's it. Congratulations. You have earned your gear badge for linkages. So go put your little robot machine together that will give you superhuman drawing powers, and I'll see you next month right here at CrunchLabs. Oh, and if you're watching this and you haven't yet ordered your BuildBox subscription from CrunchLabs, then what the heck are you waiting for? Go to crunchlabs.com with the parent, and once you're there, you can learn more about how it all works. Thanks for watching.